In this video, we will try to look at the formation of images in a convex lens by using this simulation. So we have a convex lens over here, and the F indicates the focal point or the focus of this lens, and 2F is twice the focal distance, and this candle will serve as an object. And far away written over here means infinity. So let us see what happens when we take this object and place it at infinity. It is far away over here. So we can see, since the object is at infinity, the rays travel parallel to the principal axis, as you can see, and then converge at the focus, and an image gets formed over here. What's the nature of the image? As you can see at the bottom of the screen, it's a real image. Magnification is minus 0.1x. 0.1x would mean the image is extremely small, diminished to a point, we say. So that means it's very small. Minus means it's inverted image, therefore the negative sign. So we get a real inverted image over here, which is extremely small, and that image gets formed at the focus. If we take the object closer to 2f, let us say we keep the object over here beyond 2f, the second position, then what happens? So we can see over here the image gets formed between f and 2f. Again, it's a real image, and you can see the magnification is 0.7. That means it has become slightly bigger as compared to the previous case, but still it is smaller than the object. Negative sign indicates it's a inverted image. So we get again a real inverted and an image which is smaller in size as compared to the object between f and 2f. Let us keep the object at 2f. So if I keep the object exactly at 2f, what happens? The image gets formed at 2f, and you can see the magnification over here at the bottom of the screen as minus 1x. 1 means the size of the object and the image is equal. Negative, of course, means inverted. So we get a real inverted image, same size as the object. So what we have observed is, as we go closer and closer to the lens, as the object goes closer and closer to the lens, two things. One is the size of the image is increasing. Secondly, the image is moving away from the lens on the right hand side, on this side. So as this object comes closer, the image goes further away and also increases in size. Let's see if this pattern continues. So I will place the object now between 2f and f, anywhere between 2f and f. As you can see, the image has gone further down. It has increased in size. So again, it's a real image because it is formed on the other side of the lens. Magnification is minus 2.2x. That means the image now is bigger than the object, 2.2. Negative inverted image. So real inverted image which is larger than the object, and it is formed beyond 2f. What would happen if we take the object at focus? So if I keep here, let's see what happens. So we have kept the image at the focus, and we find that the image is formed far away. Again, it's a real image. Magnification is 30x. That means we get an extremely large image, but it gets formed at a very large distance. Image formed far away. The moment we take the object between f and the lens, let's see what happens. So now what happens? The image comes on the same side as the object, and we get a virtual image. A virtual image is on the same side of the object. Magnification 2.9x. That means it is larger than the object. This is how images are formed in a convex lens. In the next video, we will deal with all these cases one by one and see once again how to draw the ray diagram, and second, what are the real life applications of all these cases. Before we end this video, let us also look at simulation for a concave lens. So in a concave lens, let us see we keep the object at infinity. The rays diverge, as we know, and we can see over here a virtual image gets formed at the focus. Magnification 0.2x. That means it's a smaller image, smaller than that. And you can remember there's no negative sign. That means it's an erect image. It's not inverted. Now in concave lens, what will happen is that wherever we keep the object, we will keep on getting the image between the lens and the focus. So let's see how. Let's keep the object over here. Again, we see virtual image because it is formed on the same side. It's an erect image and it is smaller than the object, 0.3x. Wherever I keep the object, we will get a virtual erect and a diminished image. Again, over here we are getting a virtual erect and diminished image. If I keep it at f, what happens? Virtual erect and diminished image. Even if I take it between f and the lens, we will get a virtual erect and diminished image. So in case of concave lens, we have only one type of image getting formed, which is virtual erect and diminished. Again, we will look at this case in detail and see the real life applications of both convex lens and concave lens. Thank you.